Thanks for joining us this year's National Wilderness Skills Institute. This session here is going over the resist, accept, and direct model. And joining us here is Dr. Kira Hefty. Dr. Kira Hefty is a biological scientist with the Aldo Leopold Wilderness Research Institute, whose research is focused on wildlife distribution modeling and habitat assessment, including vegetation composition and structures, patterns of biodiversity, and landscape connectivity. So today he joined us to talk about the RAD model. Thanks for having us. Thanks for being here, Dr. Hefty. Go right ahead.
Thanks, Dan, and thanks everyone for being here. Again, my name's Kira Hefty, biological scientist at Aldo Leopold. We are, if you're not familiar with the Aldo Leopold Wilderness Research Institute, we are a department within the Rocky Mountain Research Station. So we are part of the Forest Service. A lot of people haven't heard of us before. But we do kind of all matters wilderness. So a lot of our research, our research facility is research concerning issues and challenges within a wilderness context. And we do a variety of things. We have a core team of 5 research grade scientists who look at wildfire ecology issues, as well as fisheries, wildlife distribution, connectivity. And we also have 2 social scientists who look at diversity and equality of access to wilderness for recreation and cultural activities. So we do a variety of things. So if you're looking for someone who can do some research within wilderness, you have some wilderness questions or wilderness research challenges, we are here and we are happy to help. Please reach out to us. We're always willing to have a conversation and figure out how we can help. And so a large part of my job is trying to connect needs of managers on the ground to our research scientists in-house. And so that's what a lot of this project is that I'm going to be talking about. We are doing a large project around RAD as well, using the RAD framework in this context. So please reach out if you feel like you would like some science support or decision support within the wildernesses that you manage. Okay, so today I'm going to be talking about RAD. This is a framework that was created to address the emerging challenges associated with ecological transformation. And so if you're not familiar, I'm sure most of you have witnessed this to a certain extent, and ecological transformation is really that permanent conversion of some sort of ecological community to a new ecological community that was not historically present prior to some sort of disturbance event. And so a lot of times these transformations are triggered by some extreme disturbance, such as wildfire, an acute disturbance, maybe extreme storm, wind event, etc. Or they can be triggered by some sort of long-term change, such as climatically changing conditions, or a combination. So you can have an acute disturbance coupled with some sort of climatic change that triggers this new ecosystem. So a new emergence of species that weren't there historically, which then has a lot of cascading impacts on function of that system and the structure of that system as well. This is just a good visual for kind of trying to better understand how this process occurs. And so this is kind of called the ball and cup model. You might be familiar with it if you know something about state and transition modeling. But basically, we have our ecosystem in regime 1 here, and some sort of it requires energy for that ecosystem to change. And so to be pushed into a new ecosystem state than what was there historically, or what your reference community was. And so your perturbation is that energy that goes into the system. It's pushing this ball uphill. And if there's enough energy, it gets to this tipping point or this threshold, and it falls back down into a new ecosystem state. And so instead of rolling back down the hill, back into that same historical community composition that it previously was, it's kind of pushed over this threshold and cannot return back to that historical condition. So now you have a new ecosystem condition, a new ecosystem state with new suites of species that were not historically present before. And so trying to address these challenges is particularly concerning for managers in the advent of climate change. And so previously you might have had some sort of perturbation like a wildfire, some sort of extreme event, and that ecosystem, even if it was an extreme event, can gradually recover over time. But what we're seeing with climate change is that we're having exacerbated perturbations. And so we have drought now, extreme drought coupled with these acute events such as wildfire. We have high winds coupled with acute events. We have flooding, more extreme flooding, et cetera. And so what this figure is showing here is you have kind of these peaks and these lulls, and this example is just temperature. And so you have some events where you have these really high temperatures and some low temperatures, but they all kind of fluctuate around some kind of known range. And so that's called your range of variability. But what we're seeing with climate change is that we're actually leaving this range of variability, this historical range of variability, and we're kind of entering into this new territory where these extreme temperatures and lulls, so everything's getting warmer. Your hotter temperatures are getting hotter, your lower temperatures are getting hotter, and you're just having this general trend upward of mean temperature over time. And so we've left this historical range of variability into new territory, and this is called non-stationarity. So there is no longer a reference point that we can return to. The stationarity is gone within this system. And so that is what climate change is contributing to when we're thinking about transformation. And so even if we have a disturbance that an ecosystem previously could have remained resilient to or resistant to, what we're seeing is that a disturbance is triggering kind of these initial transformations. And then if we're thinking about something like forest regeneration, seedlings that might have come up in the understory following a disturbance no longer have the ability to survive because climatic conditions are now too extreme for the species to regenerate within those disturbance areas, just as an example. And so the species that are coming back within those disturbed areas could be very different, that may be more adapted to the new climatic future of that particular location. Just an example of this to give you a visual, I'm sure you're all familiar with this, but this is Joshua Tree National Park. And one of the things, one of the challenging conditions in Joshua Tree is this new emergence of non-native annual grass species in the understory in Joshua Tree, between these Joshua trees. And so previously, you could have fire within a Joshua Tree forest, but it wouldn't really carry. There wasn't enough fuel in the understory, and it was wet enough that the fires just wouldn't spread prior to about the mid 1970s. And then what started happening was these annual red brome, cheatgrass, et cetera, started invading the understory. Precipitation patterns have changed. They're having longer periods of drought. And so now we have this coupled effect of, if there's a lightning strike or some sort of human-caused fire, it's being carried farther by the fuel now, the new annual non-native grasses in the understory. But we're also having just very dry conditions. So drought coupled with fuel and high temperatures is leading to mortality, increased risk of mortality for Joshua trees, which take a very long time to grow and are very finicky about where they like to grow. And so this is an emerging threat for these particular species. And what we're being left with is the conversion of these Joshua tree forests to non-native annual grass savannas. These challenges are particularly concerning when we're thinking about the wilderness context. And so outside of wilderness, we might have some flexibility for how we address these issues, but within the context of wilderness, it's still a puzzle to figure out how to address these transforming ecological systems. And this is in particular because, as you are all familiar, wilderness are supposed to be managed within some sort of natural condition. Humans are supposed to be temporary visitors. We're not supposed to have significant permanent trammeling actions within wilderness. And any intervention within wilderness needs to be used with the minimum allowable tool. However, what we're noticing, and a lot of what RAD is dealing with, is that even though we're not perhaps having direct human impact on the landscape, climate change is inherently a human-caused problem. And so when we're thinking about preserving wilderness character or upholding wilderness character within the bounds of wilderness, that wilderness character is threatened by human activity, even if that human activity is indirect, associated with climate change. And so how do we begin to address this human-caused problem while minimizing our direct impact on the landscape? And so this is just, again, this was from the most recent IPCC report, is that stating in the very beginning of the report, this is the first page of the report, that human activities, principally through the emissions of greenhouse gases, have without a doubt caused global warming and climate change. And so we are impacting these wilderness areas. We are indirectly trampling these wilderness areas. So what can we do? What does this mean within the context of wilderness? And how can we even begin to address this within the context of the limitations of working within wilderness? So RAD is a framework that we are choosing to focus on that has a little bit more flexibility for addressing these climate change issues. And I'm sure you've kind of heard RAD. It's kind of become a buzzword in the management world, but if you're not super familiar, RAD is just another acronym. It stands for Resist, Accept, Direct. The resist portion of RAD is what we think of traditionally as our traditional management techniques when we're thinking about resilience and restoration. So we are in the resist camp, trying to return an ecological community back to some sort of reference condition. So we are trying to stop the transformation from occurring. We don't want the transformation to happen. And so that means doing some sort of activity, some sort of active intervention to resist that transformation. The accept strategy, or the accept camp of RAD, is to accept that transformation is occurring and allow that transformation to continue to occur. And so this is actually the traditional approach to issues within wilderness. So this is the hands-off approach. So we're maybe learning lessons for how this transformation is occurring that we could apply to other locations, maybe perhaps where we have more flexibility in making decisions, etc. But it's kind of a learning opportunity or a monitoring opportunity as that transformation is occurring. And then the direct portion of RAD is to direct that transformation to a favorable outcome. Perhaps you have some sort of management goal that you would like to, again, referring back to a forested system just for consistency, but if we're thinking about losing alpine species within a forested mountain system, let's say whitebark pine, but you still want to retain some sort of forested structure within that elevational zone, you could perhaps help, using assisted migration, help lower elevation species by planting seedlings of those species into these sub-alpine zones where whitebark pine previously occurred that might be better adapted to the incoming climatic conditions. And so even though you don't have the same suite of species there, the same suite of tree species there, you still preserve some of that ecological function that whitebark pine had within that elevational zone. And so directing, again, just directing that transformation towards some sort of management goal or favorable outcome. So this is, again, this is kind of just a flow chart of how these are on a graph. And so if we have some sort of deviation from historical conditions along the x-axis here, both the direct and accept strategies are kind of at the far right end of that. And so the outcome of both of those strategies is that the ecological community is going to be different than the ecological community that was there prior, the historical community, whereas the resist strategy is very much trying to maintain that historical reference point. And then looking at the y-axis here, your resist, of course, your resist and direct strategies are going to be the strategies that require the most intervention to implement, the most energy to implement, whereas your accept strategy requires no energy or intervention. We've chosen RAD to investigate interventions within wilderness to address ecological transformation for several reasons. There are many other proposed frameworks such as RRT, which is pretty popular within the Forest Service. That's resist, resilience, transform. And then there's also the adapt, monitor, protect, transform, among several others. But what is lacking within those frameworks that exists in RAD is this no action alternative, which dovetails really nicely within the context of wilderness when we're thinking about different options within wilderness, but it also dovetails quite nicely within planning processes that are already established for managers. So RAD was really built for managers to be able to use when making decisions and within their planning processes. So just for example, if we're thinking of NEPA, being able to justify the actions, proposed actions and alternative actions, as well as no action, RAD could be kind of that framework that you use to fulfill those NEPA requirements when you're running through your NEPA process. And so RAD, resist and direct are kind of your action alternatives, and then accept is your no action alternative. And then the strength of RAD, in addition to that, is that it encourages managers to make deliberate decisions. And so rather than having your no action alternative just be, well, we're not going to do anything because we can't do our preferred action, it's a deliberate choice. And so the purpose of RAD is to weigh the trade-offs of choosing a resist, accept, or direct strategy rather than just defaulting to no action. And so being deliberate about all of these decisions, whether that's an action decision or a no action decision. RAD also works across time and space. And so you don't necessarily need to use the same strategy in your entire management unit across your entire forest. You can choose to use a resist strategy in one location, an accept strategy in another location, etc. It's just based on your management goals. You could also set up an experimental design and use the 3 different strategies and see what the outcomes are as a learning opportunity. And again, across time, you can choose a resist strategy, accept strategy, or direct strategy based on your management objectives. And what you're seeing on the right here is kind of the adaptive management circle. And so if you evaluate the conditions on the ground, assess which strategy you might want to use to meet your management objectives, select that strategy and begin implementing it, monitor that strategy over time and figure out, okay, is this strategy actually allowing me to meet my management objectives through monitoring? If yes, then you can continue using that strategy. But if over time that strategy no longer seems feasible, it's too expensive, what have you, you can choose to deviate and choose another alternative strategy. So it's not something that needs to remain stagnant through time. RAD can be applied, or the best time to apply RAD is really at these decision points. And so what we found through the project that we're working on is really the best time to apply RAD is when you're in the middle of some kind of planning process and you need to justify a decision, or you need data to justify a decision. RAD really helps illuminate a decision space to be able to do that and also to meet management goals. And so what you're seeing in this right side panel here, this is kind of more the scenario planning approach. And so you may not be, especially with climate change, there is often error bars or wide confidence intervals associated with trying to project how climate change is going to influence the landscape. So you might have a few different scenarios that you're working with. Maybe you have a hotter, drier future, a warmer, wetter future, and those all have different outcomes for the ecosystem that you're working in. And so per scenario, there may be different trigger points along that trajectory. And so with a warmer, drier scenario, that trigger point might come a little bit sooner because transformation, there's going to be more pressure on that system. It may transform a little bit quicker at a quicker pace. Whereas in a warmer, wetter future, that transformation may be delayed a little bit and you have a little bit more time to make a decision. But as soon as you evaluate conditions on the ground and recognize indicate some sort of reference that is a trigger for you to be able to make a management decision, that's when RAD comes in really nice when you're trying to address a challenge because of some sort of trigger. So you're seeing some sort of transformation begin to take place, or there was a disturbance, and now you have to make a decision about what sorts of species to replant within that disturbed area. That's a place where RAD works really nicely. RAD also allows you to think not just about the ecological consequences, but the social consequences of making a resist, accept, or direct strategy. And so the idea with RAD is to really weigh all the socio-ecological, ethical, policy-based considerations with each of these alternative strategies. And so you may have a strategy that's really beneficial to the ecological community. So let's say along this y-axis here, it's predicted that the ecological responsiveness will be really high. And so if you are trying to resist a transformation, it might go in this camp, whereas if ecological responsiveness is going to be really low, it may not be worth it to resist or try to ecologically resist the transformation that is occurring. And so if it's too costly, requires too much energy, you don't have the capacity, maybe you want to choose an accept strategy here because it's not likely to be effective. Whereas societal receptivity, and so in some instances, especially if there's an iconic species, folks may be more resistant to seeing that, to have that species be lost. And so they may not be likely to accept perhaps that transformation of that community, and they want to keep that species there, versus if they are highly receptive to change, they may be more willing to accept that change or direct that change to a new community. And so what this chart here, and this is the link down here if you're interested in the paper, and I can send all of this later as well, tries to combine both those social trade-offs with the ecological trade-offs of making a resist, accept, or direct strategy, again with the intent that choosing any of these alternatives is a deliberate action, a deliberate choice. And so I'm just going to quick walk you through an example of this to hopefully help illuminate some of this. I know it gets a little fuzzy sometimes, trying to better define what resist looks like versus direct, etc. So this is Isle Royale. It's a national park that's located within Lake Superior up here. It's closest to northern Minnesota and Canada. That's actually part of Michigan. So it's the almost westernmost eastern portion of the time zone. But it is a 45-mile long island. It's about 10 to 12 miles at its widest point in Lake Superior, and it contains 132 acres of federally designated wilderness. One of the really interesting things about Isle Royale is that half the island is actually at the southern range of boreal forest in North America. And so it's a really interesting island system that includes a very important transition zone between temperate forest closer to Wisconsin to the south and boreal forest to the north. And so you have these unique island biogeography characteristics on Isle Royale. The closest mainland is Canada here, and that's about 10 miles. And so previously there was an ice bridge that could connect Isle Royale to mainland to allow for migration of wildlife species. But the migration of plant species to the island is a little bit more complicated. And so if we're thinking about migration or adaptive capacity of the species on this island, it tends to be a little bit more limited just because the suite of species on the island, it's not quite as diverse as surrounding mainland, and it's a little bit more difficult for species to get to this island and allow the island to naturally adapt to changing climatic conditions. We also have these very charismatic megafauna species on Isle Royale. I'm sure you've heard of this interesting case, the moose and wolves on Isle Royale, where we have this direct feedback Moose browse on vegetation. They particularly like balsam fir and other boreal species on the island. And then the moose act to regulate the the wolves act to regulate the moose populations on the island. And so you get this feedback where when wolf populations are too high, moose populations tend to be lower. When wolf populations are low, that's when you see this boom in moose populations, and also as a consequence, this boom in browse on Isle Royal, which can have detrimental effects if overbrowse, can have detrimental effects on boreal species, particularly balsam fir, which they do tend to prefer. And this has impacted regeneration of those boreal species on the island. Some of the climate change threats on Isle Royal include increasing air and water temperature. So that ice bridge that I mentioned earlier that previously pretty consistently connected the island to mainland Canada and Minnesota is becoming less consistent. And so this is just an image actually of wolves crossing that ice bridge. But in warm years, when the water is too warm during the winter and the air is too warm for that water to set into ice, we're losing this ice bridge. And so park service managers have had to make, and biologists have had to make, some really difficult decisions about how to manage both the moose and the wolves within the context of wilderness. And they have reintroduced wolves or introduced new wolves to Isle Royal to try to manage overbrowsing by moose on the island. And this, again, is within the context of wilderness. Some of the other climate change issues we're seeing on Isle Royal include increasing high wind events, and this is particularly concerning when considering wildfire effects. Previously, wildfire on Isle Royal was fairly frequent, but the individual fires are very small, so less than an acre. But recently they had a large wildfire for Isle Royal. It was about 100 acres a couple of years ago that burned primarily within boreal forest toward the northern part of the island, and they're seeing very low regeneration of boreal species following that fire. And that fire was predominantly carried by, was triggered by lightning. Everything was very dry. It was a drought year associated with climate change, and high winds really pushed that fire and really made it blow up on that part of the island. And so the concern following these disturbance events, when we're not seeing regeneration, is overall loss of forest biomass on the island and the inability of those limited suites of species on the island to regenerate, particularly when they are being browsed consistently by moose. And so there are intertwined effects. So the moose browse on seedlings that are trying to regenerate, but also we are losing food for moose associated with these disturbance events and as a feedback with overbrowse. So, and then this of course has cascading impacts to wolves as well that feed on the moose. And so, like I mentioned earlier, the ability of these forests to adapt to these changing disturbance regimes, to new climatic conditions, is fairly limited because of its position as an island within Lake Superior. And so this has created some challenges for managers trying to deal with this issue. Oh, and here's just an image of a simulation created through forest simulation modeling using a Landis model, if you're familiar. Looking at, this is density of balsam fir, which is an important species for moose and for forest composition on the island. Current density of balsam fir, high density is this dark green up here. And so this is kind of current density. And through climate change modeling using this forest simulation model, we can see that the density of balsam fir drastically declines. This model is projected through 21-26. So almost complete loss of balsam fir by 21-26. Isle Royal has engaged in some scenario planning to try to better visualize and start to think about how to address some of these challenges while they're just seeing in the beginning stages of this transformation. And so these are the different scenarios that they have discussed. So least change, things are likely to stay the same. So this does not include any climate change projections. Some are drought, wind, and fire. And so this is kind of one of the current climate change projections for Isle Royale. Warmer than Duluth, Minnesota, which is a kind of a mid climate change projection, middle emissions, and then your high emissions scenario where you have complete conversion of forests on Isle Royale to savanna. So you no longer have forest composition. And then the fallout for those species that will be affected by these changing climatic conditions. And so for all of these, we're seeing an uptick in temperate forest species, decrease in boreal forest species, with the exception of island savanna, where we're seeing loss of forest species in general. Moose and wolves mostly have decreasing population numbers. Moose have kind of mixed reactions depending on the scenario, but everyone within that island savanna ecosystem condition, all of these communities will be negatively affected within a high emissions scenario. And so how do we begin to address this using the RAD framework? And so one of the ideas with the resist strategy is try to reduce the potential of fire on Isle Royale. And so if fires are going to become more catastrophic and we're not seeing regeneration from these fires, one strategy may be to try to resist high intensity fire on the island. And then following fire, reseed with species historically found. And so we're trying to keep the boreal forest for as long as possible. So you would reseed with boreal forest seed species following fire. And so again, the idea of the resist strategy is trying to keep everything the same as what was historically found on the island. Within the context of wilderness, of course, this becomes rather complicated, but if this is a strategy that is justified, this would be the potential avenue to do that. Accept strategy, being your traditional wilderness approach, would just be to monitor the shifting vegetation community on Isle Royale. Try to learn a little bit more about how these communities are responding to wildfire effects. And so Isle Royale's kind of has unique soil conditions. So there is some elevational change on Isle Royale. You do have ridges, but along these ridges, which are currently forested, there's actually very little soil. And so in those areas, if you have a fire, and including the fire that they just had recently, a lot of that soil gets blown out. And so it's next to impossible to get anything to regenerate within these wildfire scars. However, in other parts of the island and lower elevation areas, it's more likely that forests will be able to regenerate in those areas. And so perhaps instead of trying to go in to resist the change, you just want to learn how these different forest communities are responding to that change, learn a few lessons that you could perhaps then apply to justify decisions farther down the road that may require more intervention. And then your direct strategy might be using something like assisted migration. So again, we're thinking about this island ecosystem, and it's very difficult for tree species to get there. So they do have temperate forest species on the island, but all of the models, simulation models that have been used so far have projected that there are so few of these temperate species present that they basically can't keep up with changing climatic conditions. And so this would either require assisting the migration of these temperate species already on the island into areas where boreal species previously were, or perhaps moving other temperate species from nearby Minnesota, Wisconsin, Canada onto the island that may be better adapted to the incoming climatic conditions on Isle Royale. Another assisted migration strategy is just, if you want to stick with using the same species, perhaps you just choose individuals of that species from seed zones farther to the south, or seed zones that are already in warmer areas. And so I'm trying to remember what the species was that's in this figure here. I think it's red oak and bur oak. And so these are two species of concern that are in this particular region. And they have a pretty large differences in climate of the same species from farther south in their seed zone to farther north in their seed zone, and running experiments to see how those seedlings are more or less successful as compared to seedlings that were originally from that northern seed zone. And what they are finding is that mortality rates are lower than seeds in the native to that northern seed zone as compared to seeds that were imported from farther south. And so there is some opportunity to move seeds that are still the same species, but perhaps are from an area that is already climatically a little bit warmer, and they are more genetically adapted to those warmer conditions. And so that's another assisted migration strategy that could be used within the concept of the direct strategy. And so, of course, there are trade-offs involved with making all of these decisions. And this is kind of the whole bread and butter of RAD, is really weighing these trade-offs to be able to make a deliberate decision. So if we're thinking in the context of Isle Royale, if we choose, let's say, a resist strategy, so perhaps some of the potential benefits of choosing that resist strategy is you can maintain that boreal forest composition, which is very unique to Isle Royale. It's very unique to have an island that has two different forest zones, a boreal forest zone and a temperate forest zone. So it's a really special thing to have on the island. It also helps support or continue to support healthy moose and wolf populations that depend particularly on that balsam fir cover. And then also that would have cascading impacts to visitor experience. So most of Isle Royale, there are quite a number of hiking trails in Isle Royale, and people go to Isle Royale to experience kind of this unique ecosystem, but in particular to hopefully see moose and wolves on the island. And so maintaining forest composition that would allow moose and wolves to continue to persist would be generally accepted as a positive thing when we're thinking about visitor use experience on the island. However, some costs associated with a resist strategy might be that it's cost prohibitive. So it takes a lot of energy to try to resist change as it's happening. It may also require significant trammeling over time to resist change. And so if we're thinking about fuel reduction activities, forest thinning, et cetera, that is a lot of trammeling, and that may or may not be something that managers want to attempt to pursue within the context of wilderness. And irregardless, those benefits may be temporary. And so we may be able to resist change for a time, but inevitably in the future, it's more likely than not that transformation is going to occur. And so if we are choosing this strategy, being intentional, knowing that the benefits of this strategy may not last for more than our projections are predicting that it will last. An accept strategy, one of the potential benefits is that it requires no trammeling action. And so very in line currently with the Wilderness Act, is not a strategy that would go under litigation potentially. It's a little bit easier to justify within the context of wilderness. It's also very cost effective because it's not an active management intervention. And then another potential benefit is that you gain important knowledge of how that system is transforming. And so you learn a little bit more about that transformation, how your system responds to that transformation before you invest time and energy into these more active management options. One of the costs of an accept strategy in this context would potentially be loss of those iconic or charismatic megafauna, so your moose and wolf populations. And so if we are in a high emissions trajectory for Isle Royale, and we lose our forest composition and we become a transformed system, trending towards an Isle savanna, that's obviously not good habitat for moose and wolves. So we might lose those species on the island over time, and that could in turn also alter visitor use experience for people coming to visit the island, who a lot of them come to visit the island to see moose and wolves. So how would that impact use by recreationists and visitors to this important national park? a direct strategy and other active management strategy, the potential benefits could be to maintain forest structure. And so you may no longer have boreal species there, but you would still have forest. And so using some sort of strategy like assisted migration, you still retain those forest species that forest structure, which could then have advantageous cascading impacts to the species, those charismatic species that rely on forest cover. So moose do love balsam fir, but they don't need balsam fir to survive. They do eat a variety of other species. And so if we have other species that are forage for moose, they could potentially continue to persist on the island. Costs or uncertainties associated with a direct strategy, again, would require significant trammeling. So if we're thinking about moving other species of trees to the island that are better adapted to the incoming climatic conditions, obviously that would require planting seedlings and perhaps changing the species composition currently on the island. And then the direct strategy comes with a greater deal of uncertainty. And so we're thinking about what sorts of species might be better adapted to an incoming climate. That involves projecting what that climate may be. And of course, there's always uncertainty involved in making those types of projections. And so the resist strategy, it's a little bit easier to predict. Okay, well, if I do a field reduction activity, it's pretty well established that that will help reduce the occurrence or intensity of high intensity wildfire. But with a direct strategy, that requires a lot more predictions and a lot more projections with climate change models. And so there is some uncertainty surrounding the success of using this type of strategy. And so just to wrap up here, some of the considerations for RAD. So the purpose of RAD is to really try to support more proactive climate adaptive decision making. And so instead of responding to these transformations that we're seeing, trying to be a little bit more proactive in thinking about how we address these challenges. And we do that through a combination of techniques, but primarily relying on science, using climate change projections, available data, trend monitoring that may exist within the area that you're managing, as well as expert opinion, learning more about the system and what folks are willing to do, what they may not be willing to do in terms of management interventions through co-production conversations, gaining input from other rights holders who have a vested interest in this landscape, perhaps for important cultural activities, recreation, livelihood, etc. And so more than just the ecosystem is being affected by these decisions, people are being affected by these decisions that use this landscape or are invested in this landscape as well. And so weighing the trade-offs associated both with the ecological portion of the challenge as well as the societal portion of the challenge, and then using those trade-offs to make intentional decisions is really the strength of RAD. Like I mentioned just previously, it can be difficult to try to project exactly what's going to happen within these systems. That often comes with a range. And so you try to bracket kind of your low emissions future to your high emissions future and trying to anticipate how extreme that transformation may be or how quickly that transformation may happen. But that, of course, involves uncertainty. No model is perfect. But what that really does is hopefully allow managers to visualize a range of potential futures for their particular management unit that they can use then as reference points. And so if they're monitoring trends over time, they have some idea of the likely trajectory or range of trajectories for their particular system. And so they can use reference points to monitor over time. And if they see some sort of trigger or it seems like that reference is heading over a threshold, then they can implement the RAD strategy, or at least have had that conversation about the RAD framework, that they are poised then to make a decision at that trigger point or at that inflection point. And so the idea of using science to try to inform this decision space is it's not perfect, but gives you some idea of the trajectory that you're on to allow you to then be a little bit more proactive. If we're having these conversations now, you'll be more poised to implement actions relevant to this decision space in the future. And again, just as a note here at the bottom, that RAD is really becomes really strong when it's produced in a co-production conversation. And these conversations can be really challenging. You have folks who, have values that may differ from an ecologist, may differ from, let's say, a rancher has different values from someone who wants to protect desert tortoise. So there may be some points of contention in these types of conversations, but generally not just with RAD, but what we've seen across other conservation projects and other decision frameworks is that having these co-production conversations up front, even though they can be difficult and can be challenging to find common ground, really make for stronger decisions, more justifiable decisions, as well as just more universally beneficial for everyone who is being affected by these decisions. Okay, well, that's what I have for my presentation. So thank you.
Thank you, Kira. Anyone have any questions? One question, Kira, that have you seen it on the project level of anyone taking the RAD model and having that line up with a range of alternatives in the NEPA process?
So we are getting there. We're still in kind of the early stages of the project. That's why I'm in Arizona right now doing site visits. But a lot of the partners that we're working with right now are kind of poised in some sort of, they're trying to develop an RMP, they're going through NEPA, and so they are poised to try to make or develop those ranges of alternatives. And so what we're hoping is that over the next year, working with them, that they can use the RAD framework within their planning processes to help better define and justify those decisions. And so actually, they're trying to rewrite their fire management plan on Isle Royale. That is one of the case studies that we're working on right now. And so they are very interested in looking at the modeling that we're doing. So I guess I'll just back up a little bit. For that particular case study, we are continuing the Landis modeling work that was previously done, but refining it a little bit to address their particular management concerns. And so when we're thinking about the resist, accept, direct strategy, what are the types of fire management strategies that might fit within that framework? So fuel reduction, assisted migration, et cetera. And so we are explicitly modeling those strategies in a forest simulation model to see what the outcome may be in the future of using those strategies over time. And so if we use a resist strategy where we're maybe engaging in fuel reduction activities, how does that either slow transformation of that forested community to an island savanna, et cetera? And so we're trying to explicitly model those, and then they can use that information to inform their forest management plan.
Great. Great. Yeah, I'm really looking forward to see how this is implemented, about public land management agencies really start using this. I mean, my mentality, this is just going to be land management in the future. It's we won't even think about it as RAD. That's just how we do business. So yeah, really exciting to see this laid out like this. So thanks, Dr. Hefty.